And now number two, question number three. With an average acceleration of minus 1.2 meter per second square, how long will it take a cyclist to bring a bicycle with an initial speed of 6.5 meter per second to a complete stop? So here also how long, they are asking you the time taken, and they have given you the values of acceleration. So in question number three, the value of acceleration is minus 1.2 meter per second square. So it's clear that acceleration is minus. Okay, there's a meaning for that, I will explain it after reading the next point. How long will it take a cyclist to bring a bicycle with an initial speed of 6.5 meter per second? So your initial speed, the initial velocity is 6.5 meter per second. And they're asking how long it will take to bring that cycle to a complete stop. Complete stop means your Vf is zero, the final velocity is zero. Here we can see Vi is positive, that means the object is going in the positive direction. And the acceleration is negative. And you know, if velocity and acceleration acts in the opposite direction. So here V is positive, A is negative. So of course they are acting in the opposite direction. So the object is slowing down. So ultimately it will come to rest. And you have to calculate the time taken. So you're looking for delta t. So again, you can look at the equation given on the right side. So the values given are Vf, Vi, A, and you're looking for time. So of course it is the second equation. So I will write the equation again. So with each problem you have to write the equation, then only you become familiar to the equation and how to use it. Okay. So Vf is equal to Vi plus A delta t. And since here your Vf value is 0, so you can substitute the values. So Vf is at 0, you can write 0 equal to Vi is 6.5 meter per second plus the value of acceleration is minus 1.2 meter per second square times t. So that's the one you need to find out, delta t. Okay, delta stands for that time duration, that's all. This t. Okay, I'm just writing t, there is no space over there, so t. And now, since you need to solve, this is 0, I'm going to bring this acceleration times t to the left hand side. Okay, so this is minus. So this minus, when you bring to the left hand side, it will become plus. So 1.2 meter per second square. 1.2 meter per second square times delta t equal to 6.5 meter per second. So delta t will be equal to 6.5 meter per second divided by 1.2 meter per second square. So that's going to be 6.5 divided by 1.2, that is 5.416. So you can round to 5.4. 5.4, and the unit, you can see meter and meter will get cancelled. Second divided by second square, so that is so this is going to be seconds. So this second square will go to the, you can see, this will cancel out. Okay, second square divided by second, so this is going to be 5.4 seconds. So that's the answer for number 3. And the next question is question number 4. Tuner's treadmill runs with an average velocity. So I'm going to erase this one. Okay. Tuner's treadmill runs with a velocity of minus 1.2 meter per second and speeds up at regular intervals during a half-hour workout. After 25 minutes, treadmill has a velocity of minus 6.5 meter per second. What is the average acceleration of the treadmill during this period? So here they are asking you the acceleration of the treadmill. And what are the values given here that you can figure out here? This is question number 4. Question number 4. It's having runs with a velocity of minus 1.2 meter per second. So your initial velocity is minus 1.2 meter per second. You may doubt, why the velocity of treadmill is given as minus, because you are facing front and the treadmills, that belt will be going backwards. So it's having since it is going back, you can take it as minus, okay? So its initial velocity is minus 1.2 meter per second and it speeds up. So it's accelerating, okay? At regular intervals during half-hour workout. After 25 minutes, so don't be confused with the time. They're telling it's a half-hour workout, but they need the acceleration during the 25 minutes time, not the half-hour workout. Okay, total time is half hour, but the calculation you need to find out is for 25 minutes. So time taken is delta t is 25 minutes. But the unit should match. So here the velocity is given in meters per second. There the time is coming in second, meters per second. Time is taken in second. So here this delta t also should be in seconds. So you have to multiply this 25 with 60 to get in seconds. So 25 times 60, that is equal to 1500 seconds. Okay, so that is the delta t, time taken. So after this 25 minutes, the treadmill has a velocity of minus 6.5 meter per second. So what's your VF? Final velocity is minus 6.5 meter per second. What's the average acceleration? So here you can directly use this equation. A is equal to this equation, first equation given in the book, okay? A is equal to VF minus Vi over delta t. And most of the students, they may have a doubt like, so is it a new equation? No. This equation and the equation given here, this second equation, both are the same. You can see if you just cross multiply and rearrange it, you'll get this equation, Vf is equal to Vi plus I delta t. Both are same equation, okay? So now we have A is equal to Vf minus Vi over delta t. So just plug in the values. So what's your Vf? Minus 6.5 meter per second minus what's your Vi? Minus 1.2. So minus and minus, this will become plus, okay? Divided by time taken is 1500 seconds. So this is going to be minus 6.5 plus 1.2. That is how much? 5.3. So minus 5.3 divided by 1500. Okay, divided by 1500. So your answer is going to be 3.53 times 10 power minus 3. So since the least number of significant figure included there is 2, so you can round this to minus 3.5 times 10 power minus 3, and the unit of acceleration is meter per second square. And if both velocity and acceleration act in the same direction, it will speed up. Okay, so here velocity is negative, acceleration also negative. Okay, so since they both having the same sign, it's going to, and the speed is going to increase. Don't think that acceleration negative is slowing down. That depends on the direction of velocity. Okay, if velocity negative and acceleration negative, the object will be speeding up. And you can see in the question, initial velocity is minus 1.2. Final velocity is minus 6.5. If you look at the magnitude of velocity, 6.5 is greater than 1.2. That minus is just showing that what is going backwards. Okay, I think it's clear to you. So now I'll move to question number 5. Okay, so let me erase this. In question number 5, suppose a treadmill has an average acceleration of 4.7 times 10 power minus 3 meter per second square. So here the acceleration is directly given. So you can write that one. Okay, A is 4.7 times 10 power minus 3 meter per second square. First part, how much does its speed change after 5 minutes? How much does its speed change means delta V, your change in velocity. So that is the question mark, okay? Delta V. This is question mark, okay? So this is the one you need to find out. And after how many minutes? So in after 5 minutes. So delta T is 5 minutes. And you can see there, acceleration meter per second square, time is in seconds, okay? So you have to convert this minutes to seconds. So 5 times 60, that is equal to 300 seconds. So now you just plug these values in the first equation, okay? Not the equation given here, the first equation given in the textbook, okay, on page number 44. That is same as the equation given in this table, the second equation. So that equation is A is equal to delta V over delta T, okay? A is change in velocity over time. That is actually Vf minus Va over delta T, okay? Here we are just looking at delta V, so delta V will be equal to A times delta T. So just take the product. Your A is 4.7 times 10 power minus 3 meter per second square times 300 seconds, okay? So that is going to be 4.7 times 10 power minus 3 times 300. So your answer is going to be 1.41. And you can look at the number of significant figures involved there. Only 2, so you can round this to 1.4. Okay, so 1.4 meter per second. So your change in velocity is going to be only 1.4 meter per second. And in B part, they are asking if the treadmill's initial speed is 1.7 meter per second, what will its final speed be? So here actually, in second part is actually a continuation of first part, okay. Initial speed is 1.7 and I'm going to erase the left hand side, okay. After that I will so in B part, they're asking if the treadmill's initial speed, so Vi is 1.7 meter per second, what will be its final speed? Okay, so you know in part A you just calculated delta V, the value of delta V, how much is that? 1.4 meter per second. It's very easy, this part. You know what is delta V? Change in velocities, Vf minus Vi. Here you're looking for Vf, so just bring this Vi to the left hand side. So delta V plus Vi will be equal to Vf. Delta V already calculated. How much is that? Delta V is 1.4 meter per second. So that you plug it over here. So 1.4 meter per second plus what's your Vi? 1.7 meter per second. So 1.4 plus 1.7, that is equal to how much? 3.1 meter per second. So this is going to be your final answer, okay? Thank you.